Okay, so now what you really should do is to translate every one of the 8 cases I already derived from the state diagram, state transition diagram, translate each one of them into JUnit test methods. I will do in this module 2 of them together with you, but the rest of the 6 will be up to you. You should really do at least some of them to really practice. It's actually quite important. Okay, we'll turn the 2 cases in the first row, basically here and here, actually also here as well. I forgot which one I will show in the module, but we'll see. I will only show you 2. Okay, we'll test for green over here. Okay, so here's the thing, right? Remember we talked about whenever you're trying to develop a test case, you want to think about, are you testing for legal usage of the method, or are you testing for illegal usage of the method? The green cell over here, for example here, when we try to increment the counter value when the current value is actually 0. So this will be considered, this green cell over here will be considered as a legal usage. On the other hand, when you try to decrement the value over here, when the counter value is actually 0, that will be considered as an illegal usage. So the expectation will be a little bit different, right? Let's see. If you want to test for the green cell, let's say incrementing when the counter value is 0, in that case, no failure and exception should really occur, and the new counter value should be equal to 1, right? If either because the counter value is not 1, maybe after you increment from 0, you will say the value is 2. Apparently, implementation is wrong. Or if any of the failure, if any of the assertion you put is actually fail, or any exception like a null pointer or index out of bound exception happen, that will be considered failure, right? Otherwise, it succeed. And for the red over here, so this row over here, this cell over here is really testing to see if the exception will be thrown as expected under the erroneous condition. For example, let's say when value is 0 and you're trying to decrement, the expected exception will be value too small exception, right? That's something I want to show you a little bit later. Okay, and so these are the common JUnit assertion methods. We actually spoke about, I believe, all of them back in the review tutorial series part 1 and part 2. The only 2 I haven't shown to you yet. One is about assert array equals, and the other one is about fail. I would say for the assert array equals, you don't need to worry about them just yet. Okay, I think I might have some example in the later modules in the course. So for now, you don't need to worry about it. But if you want to experiment with it, you can feel free and get in touch with me if you got any question. But the main thing to really learn in this module is the fail assertion. Even though it will just fail automatically, itself actually got very good value for us to test for exceptions, which will correspond to the design logic that we put for console tester 1 and console tester 2. We'll see very soon. Okay, let's see 2 very quick examples about JUnit assertions, and then we'll move on to defining our JUnit test assertions for the counter. The first one, very easy. I just want to have a point class over here. And then, okay, let me just go over with you on the iPad quickly. Okay. So what we have is this. We have the point class, 2 attributes, x and y. You can assume that they should be private. And also we got public constructor, which will initialize x and y. And also 2 public accessor returning x and y. Okay, very simple class. Let's now go over the assertions very quickly. So this part should just be more like a quick review of what you have seen in the review tutorial. Let's see the first one. If I try to create this point object, P over here, so declare P. P is supposed to store the address of some point objects. Initially, it will only be pointing to null, just by declaring that, right? Initially just null. So that's why when you say assert null over here, it's going to be true. It is null. Okay, that's why this one should be true. Check. And then assert true, P equals null. So that P is simply null. Null equals null will just be true. So that one will also pass. Good. How about this one here? This one a little bit trickier, but let's see. Assert false is expecting the argument here to be false, a boolean, like a false boolean expression. So P at the moment is actually null. Okay, so null not equal to null is actually false. So assert false will just pass, right? So that's something we also explained something very similar before. Okay, so this one here is actually a pass. Okay, so there's a typo over here, so this will be okay, right? Again, because the Boolean expression over here, null, is not equal to null, it's simply false. False will actually match the expectation of assert false. So that's why it's actually going to be a pass, right? Okay, and then let's now see the next one. If we try to see over here, assert equals, and then what about p dot get x? What's going to happen here? This one for sure is going to invoke the method on p, which is currently null, right? So if you're trying to invoke get x on null, in that case, you're going to get into a null pointer exception. In that case, this is one of the definitions for failing a test case because it's going to produce null pointer exception, right? So we know that this is going to be invoking an accessor method on null. So this will be null pointer exception, which is one of the ways for selling a test. It's kind of unexpected, right? You should never expect a null pointer exception to really occur. Okay, so now it's going to be null pointer exception. Okay, typically your test method, if you got this many lines of code in your test method, you will simply just stop right here. Okay, so let me just say this. So once you actually got this unexpected exception, unexpected exception is going to actually cause your method, test method, fail and terminates. Okay, that's what's going to happen. However, just saving some space, I'm simply just going to conceptually, I'm going to continue with some continuation of the line, assuming that this assertion here has been commented out. Okay, just for now. But if you run an Eclipse, you may have to explicitly comment this out before you can continue. All right, let's see the follow. Let's continue. Let's say we try to execute this line here. We say P is now going to be storing the address of some new point objects. So rather than pointing to over here, P is now going to point to some point objects over here. The X and Y will be 3 and 4, right? So that'll be X and Y. Okay, let's see. X and Y will be 3 and 4 over here. Let's now do the assertion quickly. If I say assert null, it's going to be failing, right? Because over here, P is no longer null. It's actually storing the address of this particular object. Okay, again, for conceptual demonstration, we are just going to assume that you actually put this into comment so we can continue, right? Okay, so just put these two into comment that already fell. What about this one here? So P is already not null. Equals null is going to be false. False is not going to match the expectation for assert true. So this will also fail. Okay, and then I'm also going to comment that out and continue. What about P not equal to null? In this case, P is something that's actually not equal to null. It's pointing to this object here. Of course, not equal to null is going to be true. So this expression over here is actually going to be true, which does not match the expectation for assert false. So it is also going to be failing. Okay, so again, it's a typo. I'll fix it on the slides. So this is going to be failing. Okay, and let's say we're going to put this also into comments, and then let's try more. What about here? When I say P dot get X, right? And here, P dot get X is going to be 3. So that will match the assert equals. So this is okay. So this is actually going to pass over here. And then finally, what about P dot get X equals to 3, P dot get Y equals 4? Yeah, of course, 3 and 4. I'm just using the conjunction here to make a Boolean expression that's compound, right? That's also going to pass. All right, so that's about the first example here. Hopefully you're okay with that. Okay, let me now go back to the slides, and then you can just, I will fix the typo. Okay, so when you download the latest slide, you will see the up-to-date version. Okay, by fixing the typo for the check or cross. Final example I want to go through quickly about a circle. Okay, let's now go over that quickly. So now for the circle example, we got a circle, and then again, assuming that's private, double radius, and also initialize with some radius, and then we're gonna get an area just by doing that, right? Very simple. So this one here, we're just creating a circle here. So C will be storing the address of the circle objects, and the attribute will be radius, right? And the radius is simply 3.4. And then I think the main point I want to review is here. We try to say assert true over here. Actually, again, this is again a typo. I really meant to say equals. Okay, assert equals. And we are saying this is the expected value, right? Just always remember this will be expected. And then this will be the actual method call for c.getArea. So this is actual. And whenever we are comparing a floating point number, as I mentioned in the review tutorial series, the decimal numbers conceptually just cannot be represented perfectly in a binary way in the machine. So that's why we have to allow some tolerance, right? That's what we said in the tutorial series. So that's why this part here is really important to allow. So this will be some tolerance. Can be plus or minus 0.01. And this is going to pass. All right. So this example here, just to review, whenever you're using assert equals, if you're comparing against certain floating point number, in that case, you definitely have to specify the tolerance level as well. Okay. Let me now go back. Okay, mathematically that should be this, but we just cannot be represented perfectly in the binary format, right? Just reviewing, repeating what I just said. So what we should do is we should really allow certain plus or minus certain tolerance number. I think 0.01 is usually a good choice. Okay, and then that's the one we just talked about. So you will pass. All right. So there's a very quick review about JUnit assertions and also its philosophy, especially about when a test method can really fail, when either unexpected exception occur or some assertion failure occur. In the next video, before that. So it's a summary table about what assertion methods are actually available if you are using the JUnit library. All right, so now in the next video we'll start talking about two JUnit test cases for the counter.